Nicholas.
Hello, my name is Suhaib Ahmed, and I would like to introduce for this topic periodic risk or data using clinic and demographic data. So I would like to talk about transformation business and healthcare in data science. So let's go for the first page and we continue. What is the data science? Data science is a field that uses scientific method algorithm system to extract insight of the database structure and understand in a simple terms. It helps us make a sense of a huge amount of information to make a better decision. Why is data science important for the companies? So we will say because the companies today really onto data science to improve their operation and make environment decision. And also, let me give the reasons why informed design making a interest relying on guesses for the induction business can use machine learning models to analyze the data, predict future outcomes. This helps the companies to improve efficiently and profitably. Also, efficiently improvement in data science helps the business identify the blockchain and production supply in chain customer service. Technicians like coloring and optimizing modeling can streamline processing, reduce the cost. Also, we will continue compositive advantage. As a compositive advantage, can we use the data science to understand the customer behavior and make threat? Polaris and recommendation system such as through US and Netflix, Amazon using machine learning to increase the customer engagement. In healthcare, data science helps predict disease, optimize, and predict the care. So let's move on. We will talk about this part for a real world application databases prediction. Imagine if we predict whether person is at risk developing, we can build a using a clinic demonstrator and age, glucose level, and BMI, body mass index. Also, the goal of the creative binary classification the model and predict the weather has debated. How the data process, that's the point we need to talk about. How the data produced. So let's say first we read the database contain information like the age and lunch and glucose, also the BMI. Next, we can clean the data by handling missing value and replacing empty entries with the mean mode value. Finally, we clean the database is ready for the analyze and where machine learning algorithm predict the database risk. Why this matter? It's good conclusion. By predict high risks and measure early doctors can make the promotion and reduce the cost and better the healthcare outcome. Also, for this we can column filter, propose, and select the column close BMA and H and outcome while we current the output refine database with the only yes we can the project for the energy and we reduce output will be refined and it is with the only essential features for the weather analyze and statistics for the purpose of the company statistics mean medium mode stand division of each other for the future. Output can explain the statistics show the mean value and the glucose and BMI and the H are 120 to 8.1 45 respectively. As a conclusion, we can say that science is a revolution that will
the relationship between two variables. For example, the older patient tends to have a higher glucose levels. This helps us to understand how the age and glucose are related. Also, we have a crosstab. The table compares the diabetic and non-diabetic patients across the age groups. For example, the young patients below the 50, most they don't have any diabetes. Also, the older patients have above the 50 age are more like to have a diabetes. Then also we have a linear correlation. This test checks how the two numbers are connected. For example, the glucose levels and the diabetes are strongly connected. The higher glucose level is often means the higher of chance of diabetes. Also, we have a rank correlation. This method is a rank data. So we check if the two factors are increased together. Example, if the age and glucose levels are ranked together, it means that we have a high chance the patient to have a diabetic. Also, we have a single sample test, hypothesis test, which is the very important. The H0 means the glucose level is equal to 100, and also H1 means the glucose level is different from 100, and the output is 0.1, which confirms the significant difference. Also, we have this table. Also, we have an independent group t-test. This compares the BMI of diabetic and non-diabetic patients. The diabetic patients have a much higher BMI compared to non-diabetic ones. Then we have a one-way ANOVA. This test checks if the glucose have a different level by age groups. The young patients have a lower glucose levels. Also, the older patients have a higher glucose level. This test shows us the age influence of glucose levels. Also, we have this data. Also, we have a machine learning workflow. Then we use a partition. We split the data into two types. The first one we use in the training data, 70% used to test the model. Also, we use the testing data, 30% used to test the model accuracy. Also, we have a linear regression learner. We trained the model to predict the glucose level using age and BMI. The model learns how to change the age and BMI to affect the glucose level. For example, if the BMI increase, the glucose levels also increase slightly. Also, we have a regression predictor. This training model is tested to see how we will predict the glucose levels. It applies what it learned to the testing data. Also, we have a numerical scaler. This checks how accurate the model by is calculating an R-square. The R-square is equal to 0.27, which means the model is so good at the predicting glucose level. The perfect scorer is 1, so we have a 0.72, which indicates the model is fit and the data is also very good. Thank you so much.
And hello everyone. Today we actually like to present we like to present our project that we've been doing with my friends for the last week of data science. So this project was like as if I tried to recover what my friends were trying to explain the whole time was our presentations about predicting risk of diabetes using clinical and demographic data. So like we are pleased to present you for our final project to introduction of data science course. So as I said before, our project title is predicting risk diabetes using clinical and demographic data. So our team members are Parkhad and Suhaib and also me, Muhammad. So we like to start our project. So our project is like data science for where we need to interdisciplinary field that applies for specific methods, algorithms, and systems we use to extract knowledge and insights of the data. So like it actually plays a crucial role in various industries from finance to healthcare, enabling data-driven decision making. So the healthcare sector that we use actually for our data science is helps to predict diseases and optimizing patient care and also improves the outcomes of the project. So the main objective that we had for our project was to develop a predictive model to identify individuals at high risk diabetes using clinical and demographic data. Our data has a global issue where early detection can lead to prevention of interventions, reducing complications and healthcare costs. So our goal for this project was to create a barrier classification model to predict diabetes based on health indicators like glucose levels, BMI, and also the age. So the overview of our project was age, glucose, BMI, and outcome. So those were the 4 things that we used for the project overview that we had. And as my friends mentioned, we use CSV Radar, we use missing value handling, and we also use column filtering. And but lastly but not the least, we use exploratory data analyze EDA that gain insights through descriptive statistics and visualizations. EDA actually it helps us to understand the data distribution, identity patterns, and detect potential outlets. The key findings were descriptive statistics. We also use histogram patterns, and we also use scatter plots. And then we also use statistical tests for single sample t-tests, independent t-tests, and also the most important was one-way ANOVA that actually confirmed differences in glucose level across age groups. And the machine learning model that we had was used to logistic regression model for classification. We use data partitioning, we use model training, and we also use model evaluation. And we also use feature engineering. We create an age category that if you are younger than 50, if you are middle age 50 to 60, and if you are older than 60, this transformation actually provide better insights into diabetes risk across different age groups. So results and discussions that we have for, and that is actually the independent test is like null hypothesis where BMI is the same for both diabetes and non-diabetes patients, and showing results with insufficient different p-value. And then if I slide to move on my report for the hypothesis where the BMI has the same mean in both groups, where BMI differs significantly from group, I would like to move my report to the next page, where one way ANOVA was the most important thing that we used for our project in our hypothesis, where the glucose levels were not different from significant between age categories, and at least age categories has significant different glucose level. And if I try to show you the next page of my project is like where we use correlation analysis and then feature engine where rule engine that we use for our young between if it's younger than 50 is young, and if it's older than 60 is the oldest, and in between that is the middle age. For actually that's the age for diabetes, not the actual age. And that formation abilities were gained analysis, and we also used for machine learning models where logistic regression model were developed to classify diabetes. And to conclude our project, we use actually something called NIME that will actually show you the workflow that we did. The data outlined in the research studies details with the prediction of morality and of the data of our of the person to live in because of the in heart risk. And this is actually how we did. And I think I would like to show you my if you remove your screen, if I need to share my screen. Yeah.
Now,
You can see now my screen sharing of the work name that we did. So this is actually how we connected our CSV reader to the missing value, the column filter, and then also to the partitioning. This is our visualization of the histogram, the scatter plot, and we also did this. We used single sample t-test to did our project. We also used independent t-test. This is the rule engine that we use, and also for our ANOVA to actually work, we had like missing parties, so we use a domain calculator to remove those things from our project. And this is a scatter plot for the main visualization we had from regression predictor and also the linear regression learner that we had for our project. And also this actually used a non-medical scorer for the project. And yes, this is actually our 9 workflow that we did from that, actually me and my friends that we were working as to
This
do.
was awesome.
And this is actually the project. Yeah, that's a scatter plot that we had to use to show the final project of the diabetes, the glucose level and the pregnancies. So if the pregnancy are higher than maybe the glucose level is risk. So finally, yeah, this is our final project, and we hope to get good projects and good marks for the final, because actually we didn't get good marks from the last final, so we had to do the makeup. So I hope you can give us good marks for this time, and good luck for the presentation. Bye. George, screen recording.